All right, gang. So today what we're going to be doing is we're going to be using equation solving to solve and some inequalities, and we're actually going to be solving compound inequalities. So it's really just an extension of what we did in class yesterday. So hopefully that will be sufficient for you. A compound inequality is an inequality that contains two or more inequality symbols. A union between inequalities is all of the set of elements that belongs to either inequality. A union is when you're looking at an or statement. An or statement. An intersection is when you're looking at an and statement. So if we're looking at a union, we're going to see the word or between our two inequalities. If we're looking at an intersection, we're going to see the word and between our inequalities. Or we're going to see something like 3 is less than x and less than or equal to 4. Okay, so, and then just to review, if that's what we see here, when we write that in interval notation, because this is less than, we would have a parentheses, then we would have 3, comma 4, because that's the end point, and since that's or equal to, that would have a bracket. So that's what we mean by interval notation. And so when we graphed that on a number line, we would have 3 with an open dot, we would have 4 with a closed dot, and we would shade between the two. Okay? So that's just a review of what we did yesterday. So let's just try solving some of these inequalities. So these first two are just compound inequalities, and they are and inequalities. So since they're and inequalities, we're just going to solve them. And then we're going to graph it, and then we're going to write our answer in interval notation. So what we do first here is we see that we find our x. Our x is in the middle. So then we look, is there anything being added or subtracted to x? No. Anything being multiplied by x? Yes. So it's 3 times x, so we're either going to multiply by 1/3 or we're going to divide everything by 3. Now 3 is positive, so since it's positive, that doesn't change our inequalities at all. 6 divided by 3 is 2, is less than x, is less than or equal to 5. Beautiful. Now we have x all by itself in the middle. And x is between these two numbers. So when I go to my number line, I'm going to have a 2 that has an open dot. I'm going to have a 5 that has a closed dot. And because x is between those, I'm going to connect them. Okay? Likewise for letter B. Except this time we have something being added or subtracted to the x. So we start by adding 1 in every spot. So -6 plus 1 is -5, is less than or equal to 5x, is less than 10. And now we want to get x by itself, so we divide everything by 5 because that's what's with the x. So we have -1 is less than or equal to x, which is less than 2. So when we draw our number line, we're going to have a -1 on it, and we're going to have a 2. -1 is less than or equal to, so that's our closed dot. And then it's going to an open dot at 2. Now I forgot to write my interval notation. So my interval notation says it's an open dot at 2, so that's a parenthesis at 2, and a closed dot at 5, so that's a bracket at 5. Oh, that is an ugly looking 5, but you know what a 5 is. Here we have the same thing to write our interval notation. So this is a -1 and it is closed, so that's a bracket. And then a +2, and that's open. So that's a parenthesis. All right, taking a look at the next one. Well, I can start by subtracting 3 from both sides. And again, this is an and because my x is in the middle. So when I subtract 3 from everything, I have negative 1 is less than or equal to 1/2 x is less than or equal to 4. So now I want to get x by itself, so I'm going to multiply everything by 2 to get rid of that fraction. So 2 times negative 1 is negative 2. 2 times 1/2 x is x. And 2 times 4 is 8. And since we multiplied by positive 2, that didn't change my inequality. So if I graph this on my inequality, I'm going to have a negative 2. That's going to be a closed dot. I'm going to have 8. That's going to be a closed dot. And I will connect the two between. All right, so now we're switching to or. You'll notice that we have two inequalities here and we have the word or in the middle. Or is where we're going to do, it either has to be an answer to the first one or answer to the second one. So we're actually going to shade every part that's an answer. Over here, we're shading the overlap part, but over here, we're on the left side, we shaded the overlap part, but on the right side of this equation for part D, we're going to solve our equation. So when we look at our answer for for letter D, the first one says x is greater than 5. All right, so we know x is greater than 5, so I know that on my number line, I've got 5, and it says x is greater than 5, so I've got an open dot, and I'm going the greater than way. Okay, when I come up here, I divide both sides by 2. And so then when we divide by 2, we have x is less than or equal to negative 2. So that means I have a closed dot at negative 2. And then since it's less than negative 2, that means it's away from 0, so this way. So these are the kinds where we're going to have middle empty. So when we write our interval notation for this, we're going to go from negative infinity to negative 2. And then we're going to start at 5 and go to positive infinity. So we have two arrows. We've got two inequality symbols there, or two intervals. So now when we come back here, because I forgot to write my interval notation again, we have closed dots on both of these. So this is going to be from negative 2 to positive 8. All right, so now we have two more OR questions to solve here. So if we move on to the OR questions, we're going to solve this first inequality. It says 2 times the quantity of x plus 3 is less than or equal to 0. So when we solve that, we do 2x plus 3, which is really 2x plus 6, because 2 times 3 is less than or equal to 0. We subtract 6, so 2x is less than or equal to negative 6. And then we divide by 3, and x is less than or equal to negative 3. Now we get a negative answer, but we didn't divide by a negative. So that means when we look at our number line, we're going to have a negative 3. And it says that x is less than or equal to that. So we've got a closed dot. And we're going left. All right, here we have x minus 1 is greater than or equal to 7. So we add 1 to both sides, and we find out that x is greater than or equal to 8. So that means on our number line, we've got an 8. We've got a closed dot on it, and it has to be greater than, so that means we're going to the right. So when we write that in interval notation, we're going to go from negative infinity to negative 3, and that's going to have a bracket. And then we're going to have a bracket at 8, and we're going to go to positive infinity. Okay? And then our last example together, same deal. We're going to start by adding 1 to both sides. So we have 3x is less than or equal to 6. So that means we divide by 3, so we find out that x is less than or equal to 2. So on my number line, I would have 2, and it would have a closed dot, and for less than, it would go this way. So here I'm going to divide by negative 10. Now when I divide by a negative 10, that changes my inequality. So now it's negative, instead of negative 10, x is less than 20, it's now going to be x is greater than, and 20 divided by negative 10 is negative 2. So at negative 2, I have an open dot, and I'm shading greater than all the way. So when I look at this, my whole number line is shaded. So my interval is actually all the way from negative infinity up to positive infinity. Because it can be, our answer could either be something that's less than 2 or greater than negative 2. So it could be positive 5, because that's greater than negative 2. It could be less than 2, which could be negative 5. Okay? So what I'm going to ask you to do is I'm going to ask you to open ClassKick and, whoops. I'm going to ask you to open ClassKick and complete the pre-college math assignment entitled 10-22-21, Compound Linear Equalities. All right, have a great day.